This is an AQA GCSE Chemistry question based around the topics chemical reactions and energetics. I'm going to recommend that you try to answer each section, pausing as you go, and then review your answers when you're done. So here's part A, part B, part C, part D, part E, part F, and finally part G. And you can see that this is an 11-mark question. So if you've had a go, let's carry on and review and see how you've done. So question A, it's about energy changes in reactions. Ammonium nitrate dissolves in water. The change is endothermic. Where could we use something that's endothermic? Well, we have to remember for this that an endothermic reaction will take heat energy from the surroundings, causing the temperature of the surroundings to decrease. Now, we don't want that from a hand warmer, we don't want that from a self-heating can, but we do want that in a sports injury, or more commonly known, ice pack. So the correct answer is a sports injury pack. Moving on to part B, quite a lot of information here. We've got a method which shows us how we're going to carry out this practical. 25 cm cubed of potassium hydroxide in a glass beaker, add 5 cm cubed of dilute sulfuric, stir it, measure the temperature, repeat steps 2 to 4 until we've got 30 centimetre cubed, so that's 5 cm cubed increments of sulfuric acid, and then we look at the results. So for figure 1, we've got the scales of 4 thermometers, A, B, C and D. Which of those are we going to use to measure what we're looking at here? Well, taking a look at what we've got at the moment, we want our answer to go to 0.1 degree. And if that's the case, we have to go for the thermometer that has the resolution to do that. Moving on to part C, energy is lost to the surroundings during the reaction. What type of error? Well, that's not human error. It's not been caused by you. It's not random error because it's something that would happen fairly consistently. And it's not zero error. We tend to think of that as being where we maybe haven't zeroed the scales before we use them. It is a systematic error because that energy will be lost every single time and it will have the same impact. On to part D, the student used a glass beaker for the reaction. Name a container the student could use instead of a glass beaker. Well, we want something that minimises or prevents heat loss. What you would commonly use in this circumstance is a polystyrene cup. That may have been referred to as a calorimeter. For the next one, it's a relatively straightforward question. You simply have to take the time to plot your results carefully. So I've plotted my points in here. I've then added my line of best fit. And from there, I need to answer some questions using it. So taking a look at F, you can see I've transferred the graph over again. This will be read from your graph and your line of best fit. It had to be extrapolated back to the y-axis, and we can see on here that that takes it to 20.2 degrees C. Finally, we get to part G. Another student repeated the investigation, obtained an anomalous result, but it was lower than expected. What could have caused the anomalous result? The key thing I want to point out here is that it says tick 2 boxes. If you don't read the question carefully, lots of people look at multi-choice, assume it's a single answer, and they've missed out on half of the potential marks available. In terms of the correct answers, the mixture was not stirred, and too little sulfuric acid was added. Both of those would lead to a lower than expected result. Higher temperature would lead to a higher than expected value, as would adding too much of the potassium hydroxide. And the thermometer not being accurate, well, it would be systematic all the way through. Okay, that takes us to the end of the question. Thank you for listening.